Good morning, my name is Abby Ozer and this is the reading week 3 for Physics 2211. As for the main physics idea this week, we were focused mostly on fundamental interactions and clarifying previous methods. To more thoroughly explain the latter, we looked at how we've been using calculus without even realizing it. As someone who loves math and was looking forward to the calculus in physics, this caught me a little off guard, because I had also been asking myself, when exactly are we going to start using calculus? To realize that we were going back to the very fundamentals, adding up tiny changes again and again to see the results of a big change, was oddly comforting due to its familiarity. Seeing the equation v final equals v initial plus the integral of f net divided by mass with respect to time with limits of the time interval puts velocity, a not unfamiliar concept but not a comfortable one either, into understandable terms. The other aspect of clarifying previous methods was defining and explaining acceleration. The definition is change in velocity over change in time, and we had been using this quantity, we just didn't name it acceleration. Newton's second law, in its traditional form, was also discussed, as the vector acceleration is equal to f net divided by m. This formula is often seen in high school physics classrooms and is familiar to many, myself included, but introducing it as a secondary form rather than the first topic in forces seems new. As for the interactions, videos this week covered impulse, gravity, and the electric force. Impulse is an interesting concept, looking at the change in momentum as a function of net force and time duration. The forces are so large, but are reduced down to normal size due to the small delta t. I feel that collisions are going to be a very interesting and important part for the chemistry aspect of chemical engineering, as a large part of creating a new material is seeing how it responds to damage, or collisions at the atomic level. Although I'm going into chemical engineering, the crossover of materials science engineering is fascinating, and knowing how to calculate the extent of a force's effect on a new material seems like it would have widespread uses. A second concept was gravity. While we're all very familiar with gravity, however, this was Newton's law of universal gravitation, which takes into account both masses and the distance. This somewhat complicated formula, which is g, a constant, times m1 and m2, which are the masses of the two objects in our system, divided by the square of the distance between them times the unit vector of change of position, can be simplified and approximated to force g equals mg, or the mass of the object in question times negative 9.81 meters per second squared. We can approximate this in such a way because near the surface of the Earth, the gravitational force is nearly constant. This is due to the difference in scale between the Earth and any other object we are investigating. While I knew this law existed, I was also not overly confident in my understanding of it, so this was a nice review and elaboration. The last interaction was the electric force. Interestingly enough, the formula for the electric force on one charge by another is set up very similarly to the gravitation law. However, while gravity is an attractive force only, the electric force can be either attractive or repulsive, depending on the signs of the charges. Like charges repel while opposites attract. We multiply the magnitude of the two charges and divide by the magnitude of the position vector squared, then multiply all of that by 1 over 4 pi epsilon naught. This is also called Coulomb's law. As a whole, the most confusing topic was the momentum law. I understand what it looks like, but I have yet to mentally connect all the dots needed to bridge from one section of knowledge to the other. However, the textbook is always a great resource for extra information as well as worked examples. There, the steps are very clearly laid out and explained at a basic level for all to understand. In addition, the article Momentum Change and Impulse Connection by the Physics Classroom also explains how momentum works and what impulse looks like in a real-life situation. The article also explains a rebounding collision, as they call it, or as I learned in my high school physics class, an elastic collision. This helped clear up some of the confusion regarding where the momentum was going and how it was conserved. So overall, it's a pretty good source for explaining the momentum principle better. This has been Reading Week 3, and thank you for listening.